Alright, so you're welcome once again. We're looking at Gauss law, and as a matter of fact, it's still another core part of electrostatics that cannot be ignored. Okay, so what then is Gauss law? Okay, Gauss law states that the electric flux on a surface is directly proportional to the charge enclosed by the surface and inversely proportional to the permittivity of free space. So what we are saying is that the electric flux is denoted as this. This is called phi. This is called phi, and it's why we are saying that it is equal to the charge all over permittivity of a vacuum or permittivity of free space. So this is directly proportional to this, but inversely proportional to this. Remember epsilon naught, which is our E naught. The value, remember that the value is 8.85 times 10 raised to power minus 12 Newton meter square per coulomb square. Don't forget that. That's the value. The Q is our charge. Of course, Q is our charge, and of course, it is measured in coulombs. Alright, so that's what it explains basically. Alright, so that's what Gauss law is all about. Charge all over permittivity of a vacuum. Alright, so now what then is electric flux? Okay, electric flux is generally defined as the product of the electric field intensity and the cross-sectional area of that particular material. So a particular material has an electric flux when it has an electric field intensity and a cross-sectional area. So what we are saying is that the electric flux is E times A, which is EA. Now E is electric field intensity, A is cross-sectional area. Alright guys, so A has a formula. The formula for A, that is if you're not giving A is equals to pi d squared all over 4. Alright, pi d squared all over 4. Okay, so basically we have EA as the formula for electric flux. This is the general formula for electric flux. But guys, if you are given charge and you're going to look for electric flux, just divide charge by epsilon naught. Don't wait for them to give you the value for epsilon naught. Have it in mind that it's a constant 8.85 times 10 to the power minus 12 Newton meter square per coulomb square. It will not change. Alright, so now basically if we are to now put this formula into this, phi will be equals to E pi d squared all over A. Alright, E pi d squared all over A. Now the unit for the electric flux of a material is Newton meter squared per coulomb. Alright, Newton meter squared per coulomb is the unit for the electric flux of a material. Alright, sorry. Okay, this over 4, sorry, this over 4, okay, this over 4. Okay, take that correction. This over 4. By the time we substitute this into A, that's over 4. Alright, so now that is that. Let's quickly look at the question. Please take down. Let's look at the question. Now, determine the electric flux of a material. Determine the electric flux of a material with an electric field intensity. With an electric field intensity of 1.68 newtons per coulomb. With an electric field intensity of 1.68 newtons per coulomb. Given that it has a wire of diameter. Given that it has a wire of diameter 0.25 meters. Given that it has a diameter, a wire of diameter 0.25 meters. Alright, so we are being told to look for the electric flux of that material. Alright, so let's quickly delve into that. Now we have to list our parameters first. Now remember that the question gave us electric field intensity to be 1.68 newtons per coulomb, and we are also giving distance. Alright, we are giving distance, but in this case it's diameter. So the diameter is 0.25 meters, and we are told to look for the electric flux. We are told to look for the electric flux. So how do we navigate through this? It's very simple. We know that our formula for electric flux is EA. Alright, we have our E, but we don't have our A, but we can look for A. So remember that A is pi d squared over 4. Diameter that we are given is what? 0.25 meters, right? So you can easily plug it into the formula. So A will be equals to 3.142 times 0.25 all squared divided by 4. So if we do this, what are we going to get? So if we say 3.142 times 0.25 all squared divided by 4. So we are going to be getting 0.049. Is that correct? So 0.049 meters squared. All right. So the units for area is meters squared. So basically that's our A now. So our electric flux now, we have newtons per coulombs of 1.68 newtons per coulombs times 0.049 meters squared. Okay. Now, so basically, if we do this, we are going to have 1.68 times 0.049. All right, 1.68 times 0.049. This will give us 0.08232. All right. So now, if you look at this, basically, if you look at this, you realize that we have newtons per coulomb times meter squared. Newtons per coulomb times meter squared. So what does it mean now? What do you think now? What did I give you as the unit for electric flux? Newton meter square per coulomb, right? Okay, does it correlate with this? Does it agree? Beautiful. So this is Newton meter square per coulomb. This is the answer. So these are electric flux. Alright, that's the electric flux. So one thing you need to understand is that sometimes the diameter of the wire or the diameter given to you in the question can be in millimeters. Don't forget that millis times 10 raised to power minus 3. Don't forget that. Alright, so now let's look at another question. Let's delve into another question. Take down. Now, calculate the net charge. Calculate the net charge of a Gaussian surface. Gaussian is spelled G-A-U-S-S-I-A-N. Calculate the net charge of a Gaussian surface which has an electric flux of magnitude. 1.85 times 10 raised to power minus 3 Newton meter square per coulomb. Okay, which has an electric flux of magnitude 1.85 times 10 raised to power minus 3 Newton meter square per coulomb. All right, calculate. We are told to calculate the net charge. Net charge is Q. Net charge means total charge. Are we together? All right. Of a Gaussian surface. So this one we have been given the electric flux and we are told to look for net charge. Okay, that means that we have to. Okay, let's state our parameters first. Okay, we have, of course, just one parameter, our electric flux, which is 1.85 times 10 raised to power minus 3 Newton meter square per coulomb. And we are told to look for Q. And of course, we know that the best formula to use here is electric flux equal to Q all over epsilon naught, according to Gauss law, right? And we're looking for Q, right? Remember that epsilon naught is what? 8.85 times 10 raised to power minus 12, right? So 8.85 times 10 raised to power minus 12. Okay, so it means that, okay, to make Q solid of formula, Q will be this times this. So our electric flux times our permittivity of free space is what will give us our charge. We cross multiply. Okay, so now the electric flux in this question is 1.85 times 10 raised to power minus 3 times the permittivity of the vacuum is 8.85 times 10 raised to power minus 12. So by the time we multiply this, so we have 1.85 times 10 raised to power minus 3, then times 8.85 times 10 raised to power minus 12. What would this give us? 1.637, right? Times 10 raised to power minus 14, right? Is that what you're getting? Okay, so 1.637 1.637 times 10 raised to power minus 14 watts coulombs. That is our final answer. Alright, that's our final answer. So this is the net charge Q. That's the net charge Q. Alright, so now basically another thing we would be doing, alright, now is to critically look at still electric flux, but now we're looking at the electric flux on a surface that forms an angle. Alright, electric flux can be on a surface and form an angle. So when an angle is formed, how can we get the electric flux? Alright, so now put down electric flux on an angular surface. Electric flux on an angular surface. Okay, so when an angle has been formed, how do we get the electric flux? Alright, electric flux on an angular surface. Take down. Now, the electric flux on a surface which forms an angle, is given as phi equal to EA cos theta. Given as phi equals to EA cos theta. So that cos theta there is what is indicating that yes, there is an angle. Please don't mistake this for this. This is phi, this is theta. Theta is the angle that is formed. So EA cos theta is the formula that will enable us to get the electric flux of a surface when an angle has been formed. Are we together? Beautiful. Alright, so remember your theta is the angle, then cos, of course, your E remains your electric field intensity, your A remains the cross-sectional area. Let's look at one example. Take down, guys. Alright? Take down. Now, a surface enclosed by an electric field intensity. A surface enclosed by an electric field intensity of 1.65 times 10 raised to power minus 4 newtons per coulombs. A surface enclosed by an electric field intensity of 1.65 times 10 raised to power minus 4 newtons per coulombs occupies an area of 2.66 meters squared. Occupies an area of 2.66 meters squared. Alright? Alright. Determine the electric flux. Determine the electric flux if it forms an angle of 60 degrees. Determine the electric flux if it forms an angle of 60 degrees. So these are the three parameters given in the question. This is your E, this is your A, and this is theta. Okay, so we have stated the parameters already. These are E, these are A, these are theta. So we are being told to look for phi, which is EA cos theta. So this will simply be 1.65 times 10 raised to power minus 4 times 2.66, okay, then times cos 60. Alright, where you have cos theta, you say cos 60. So let's multiply. So while 1.65 times 10 raised to power minus 4 times 2.66 times cos 60 degrees. So I'm having 2.1945 times 10 raised to power minus 4. Right? So this is let's just say 2.19 times 10 raised to power minus 4 newtons meter squared per watt coulombs. That is our final answer. That's our final answer. So you have to be able to identify every parameter that you are given, at every point in time when you see a question. Okay, when you see a question, you need to know the formula to use. Alright, list your parameters first. Okay, listing your parameters first would enable you to actually detect how to calculate every question you come across. Alright, so this is our final answer. So let me give you an exercise. That will enable you to actually understand this better. Take down guys. Take down. Determine the cross-sectional area. Determine the cross-sectional area of a surface. Determine the cross-sectional area of a surface in a conductor. In a conductor which has an electric field intensity. Which has an electric field intensity of 2.16 times 10 raised to power minus 3 newtons per coulomb. I said determine the cross-sectional area, okay, in a conductor which has an electric field intensity of 2.16 times 10 raised to power minus 3 newtons per coulomb and forms an electric flux of 0.065 newtons meter square per coulomb, and forms an electric flux of 0.065 newton meter square per coulomb at an angle of 45 degrees. At an angle of 45 degrees. So attempt this question, and of course drop your answer in the comment box, and of course I will review your answer and tell you if you're correct or not. Okay, so like I said, if you find this video fascinating, do well to share, do well to like, and as well, if you've not subscribed, hit the subscribe button so you can get notifications on our subsequent videos. Thank you.